Okay, let's look at this part here on the practice where we have to actually use the coordinate geometry. So it says on number 25, the vertices of a figure are given below. So here's your vertices, A, B, C, and D. I'm going to plot those. A is at 3, 0, over 3 up 0. B is at 3, 6, 1, 2, 3, 4, 5, 6. That's B, and that's A. C is at 2, 1, 2, 3. And D is at 4, 3, 4, 1, 2, 3. Okay, so it says connect the points so that they form a convex polygon. Remember, convex means it doesn't cave in, so I'm going to connect my points here. That's a convex quadrilateral. Okay, it's a convex quadrilateral. So now classify the figure and then show the figure as equilateral. Well, I'm going to classify the figure first. What kind of figure is this? Well, remember all that work we've been doing with slope and distance? Well, let's look at these. I'm going to do distance. So I'm going to find the distance from A to D. From A to D. So my distance from A to D is going to be 3, 0, and 4, 3. So if I do my distance formula, hopefully you can see it. If I do my distance formula, I have the two x coordinates, which are 3 and 4. So I've got 3 minus 4 squared plus the two y's, which is 0 and 3. 0 minus 3 squared. 3 minus 4 is -1, so I've got -1 squared plus -3 squared. So that's going to be 1 plus 9. So that's going to be square root of 10. So this side is square root of 10 in length, right? That's one distance. Okay, let's do the next distance. Now we're going to do BD. BD is here and here. So I'm going to do the distance for BD. I'll put BD there. That was 80. So I've got the square root of, for B and D, I've got 3 minus 4 again. And then I've got 6 minus 3. 3 minus 4 is -1, so I got -1 squared plus 3 squared. And if you look at that, 1 plus 9 is what again? 10. So this is the square root of 10. So far we've got two congruent sides, right? These two guys are the same length. So let's keep going. Let's find BC. BC is these two guys. So I'll do the distance here. We'll do the distance from B to C. My two x's for B and C are 3 and 2, so I've got 3 minus 2 squared. My two y's for B and C are 6 and 3, so I've got 6 minus 3 squared. That's going to be, and I should have put square roots over these because they are square roots. Don't forget your radicals. 1 squared plus 3 squared, and here we go again, same thing, right? That's going to be the square root of 1 plus 9, which is also square root of 10. So now I've got 3 congruent sides, right? So let's see if we can actually prove the fourth one is congruent. So what's my last one? CA, C and A. So the distance from C to A, I'm going to have my two x's. I have A, we'll do A and C, 3 and 2. So I've got 3 minus 2 squared plus 0 and 3, 0 minus 3 squared. So I'm going to have -1 squared and, or sorry, 1 squared and -3 squared. And what's that going to end up with again? Square root of 10. So you've just proven that this is equilateral. All of the sides are square root of 10. So what does that mean if it's a quadrilateral and all 4 sides are congruent? For sure, I know it's a rhombus, right? I know you liked my shirt. I know for sure it's a rhombus because all 4 sides are the same length. I established that with the distance formula for all 4 sides. They're all square root of 10, all the same length. Now the question is, can I get any more particular with this? Once you know it's a rhombus, really the only other specific you can give is if it's a square. Now, we don't necessarily know if it's a square, but we can figure it out. In order for it to be a square, that means that every set of two sides that are neighboring have to form a right angle. Okay, so they've got to be perpendicular. So what I'm going to do is I'm going to find some slopes here. And I'm going to come up here. I'm going to try to find some room where you guys can see it. Okay, so let's do some slopes here. I'm going to do the slope first of all for, let's do BD. Slope for BD. Okay, if you remember the slope formula, it's change in y over change in x. Y minus y over x minus x. So find the slope of BD, this one right here. So I'm going to look at B and D. My y coordinates for B and D are 6 and 3. My x coordinates are 3 and 4. So the slope of BD is 3 over negative 1, which is just negative 3. So the slope of this one is negative 3. We use m to indicate slope. So let's find the slope of DA. The slope of DA, again, change in y over change in x, and we're doing DA. We're going to do DA. So I've got 3 minus 0, or you could do 0 minus 3, it doesn't matter. I chose D first, so 3 minus 0, which means I have to choose the 4 first, 4 over 4 minus 3. So I've got 3 on top and 1 on the bottom, so the slope is 3. Now let's compare. If they're perpendicular, meaning 90-degree angles, they have to have opposite reciprocal slopes. Not only are they opposite signs, but they are reciprocals, meaning they're flipped. So these are opposites, right? Negative and positive. But 3 and 3 are not reciprocals. So this is not perpendicular. Therefore, rhombus is all it is. It's not a square. These are not perpendicular. Therefore, they don't make a right angle. Perpendicular would be like positive 1 over 3 and negative 3 over 1. You see the difference? Different signs, flip. So that's how you can determine what kind of figure you have. Remember, if it's got one pair of parallel sides and one pair of non-parallel sides, it's a trapezoid. If 4 sides are congruent, if both pairs of opposite sides are congruent, it's a parallelogram. If all 4 sides are the same and congruent, it's a rhombus. If you can establish 90-degree angles using the perpendicular, it's either a square or a rectangle, based on what else you've established. If it's a trapezoid, if it's got one pair of opposite parallels and one pair of not parallels, and the 2 non-parallel sides, which are the legs, are congruent, then it is an isosceles trapezoid. So that's how you classify.